get this resistance, right? So so the thing that we understood was this resistance, right? And this thing we have already understood in our 10th standard, I guess, that it is so it works, right? It works against the motion of the electrons, right? Wherever the electrons are moving, so it try to oppose the motion of the electrons. That is the resistance, right? So it works against the motion of electron, and it opposes the motion of electron in the conductor. Right, so that opposing force is called resistance. And what are the parameters this resistance is dependent upon? So this resistance is dependent upon dependent on the length of the wire, right? Then it is also is dependent on the area of cross section of wire, right? And then it is also dependent upon is also dependent on the nature of the material, right? And it is also dependent upon, so resistance is also dependent on the temperature of the surrounding or temperature of the wire. Right. So these are the parameters on which the resistance is dependent upon. This thing we will talk about later, but yeah, let us talk about all the other things, right? So this resistance is directly proportional to depth. This resistance is inversely proportional to the area. And if we remove this proportionality constant, so we'll get this rho, and this rho represents the nature of the right, and this is called resistivity. Right, so resistivity, how to be represented? So rho is resistivity, right? And it is also dependent upon some parameters, but that will study later. Right, so this is called resistivity. And then we have another thing which is called conductivity. So conductivity is so we know that what is resistivity. So it is trying to oppose the motion of the electrons, right? The charges are flowing, the electrons are flowing, and the opposing, so the work which is being done by this resistivity. So this is trying to oppose the motion of the electron. But the conductivity, on the other hand, it will try to enhance the flow of the current, right, or flow of this electric charges. So conductivity is a reciprocal of this resistivity, right? And this is 1 by rho, and conductivity is represented by sigma. So this is 1 by rho. Yes, this is conductivity. So we have two things. One is resistivity, the other is conductivity. And let us do one question, and after that we will talk about the other property of the conductor. So let's say that the length of the wire is increased by 25%, and the area is decreased by 25%. So length is increased, area is decreased. Find the new resistance of the wire. Right. So initially, let's say that we have this wire. Right. We had this wire. It had some area of cross section, and it had some length. Right. And this material is resistivity is. So initially, right, we have the resistance that would be how much? Rho L by A. And then what we are doing? So in the next part, the length has been increased. So length has been increased, and it has become, let's say, new length L prime, and its area is also decreased. So this area has become A prime, right? And we are using the same wires. What will happen to the resistivity? Will it change?
Yes, sir.
Are we using the new material?
No,
Yes.
sir, we're not.
So we are not using the any other
Yes,
material.
sir.
So the material is same. So resistivity will be
Same.
same, right? So if this is a copper wire, and if we are stretching the copper wire, then the resistivity will be same, right? Because this is again a copper wire. Material is not changed. So rho would be same. Now we have to find out that new resistance, right? New resistance would be how much? That would be rho L prime divided by A prime. So now we have to find out what is L prime, what is A prime. These are the two things that we are trying to find out, right? So we know that length of the wire is increased by 25%. So whatever the length was, this new length, this is increased by, right? Okay, Mir has joined. Yes, hello, Mir, assalamu alaikum.
Walaikum Assalam, sir.
Sir?
Yeah. So L prime is what this is length plus increase in 25% of length. This is the new length, right? We had this old L length, and this is increased by 25%, right? Right, Arsalan and Mir?
Yes, sir.
So what would be this thing? This would be L. plus 25% is 25 by 100 of meaning multiplication of it. So 25%. So this would be how much? This would be L plus L by 4, which is how much? 5L by 4. So the L prime, the new L prime is 5L by 4. Right, clear? Now, what about the area? So the area has been decreased. So this area is decreased. So what we should do? Plus or minus? What we should write? It is decreased. So the new area, what should we do? Should we subtract or add? Area is decreased by 25%. So what should we do? Add or subtract? Yes, Arsalan and me. Still, what do you guys think? We should add or subtract? Yes, area is decreased, right? So
Yes,
if
sir. So subtract.
subtract, right? Subtract by 25% of the area, right? So this would be A minus 25% is 100 of its multiplication. Again, this is 4. This would be how much? This would be A minus A by 4. So this would be how much? LCM is 4. This is 4A minus A. So 3A by 4. This is the new A. So now we will put all these values, L prime and A prime, into this one. Right? This is our new resistance. This would be how much? Let me write it in here. So R prime is rho L prime A prime. L prime is how much? That is 5 by 4L. A prime is how much? That is 3A by 4. So by 4 will cancel. And we will have what? 5 by 3 rho L by A. So rho L by A is how much? If we look back at the question, rho L by A is port resistance, right? So R prime would be 5 by 3 and R, right? Because R is old rho L by A. This is our. And if somebody wants to calculate the percentage increase or decrease, so we will subtract it. So we will subtract it with the percentage increase. So if somebody wants to calculate that also, so what we will do, we'll minus subtract R minus R, divide by R, and then multiply by 100. So that is the percentage increase, right? So R prime is 5 by 3R minus R divided by R into 100. This would be how much? 5R minus 3R divided by 3 divided by R. So 2R divided by 3R into 100. R will cancel and this would be how much? 200 by 3. So this would be how much? This is 3 5 the 3 6 the 80 and then what do we have? 3 6 66.67%. So resistance is increased by this much amount, right? Yeah. So is this thing clear, guys? What did we do? We had this wire. We increased the length of the wire by 25%. We decreased the area by 25%. and then we wanted to find the new resistance. So this part is done. We have already found out the new resistance, but we can also find the percentage increase or decrease, right? So that so please note it down from here, right? Yeah, please note down this part, and then we'll yeah, then we'll talk about the other topic. Yeah, whenever you guys want me to scroll down, please tell. Yeah, whenever you guys want me to scroll down, please tell.
Yes, sir.
Yeah, whenever you guys want me to scroll down, please tell.
Yes, sir.
Yeah, then please. And if you guys have any doubt in the question as well, so you guys can ask. Yes, noted, guys.
One more line, sir. This last few words.
Whenever you guys want to scroll down, please. Let me up.
Yes, sir. Done. Yes, sir. Done with this part, sir. Scroll down.
Oh, done. Okay, so then
Yes, sir. Done.
done. Okay, then please quickly note down this part.
Yes, sir. Done.
Okay, so now the next thing that we have to understand. We understood about the Ohm's law, right? That Ohm's law was the macroscopic form. So now we have to understand the microscopic form of Ohm's law. That first we have to understand what is current density, right? So it is the amount of current passing through a unit area, right? So this is represented by J, right? And it is a vector quantity. It is a vector quantity, right? And this is represented by J, which is I by A, right? So this would be, so SI unit of this current density would be how much? That would be ampere per meter square. So that would be, yeah, this is looking like same. So this is area, this is current. Let me write it down. So J is I by A, where J is current density, and then I is current, A is area, right? And its unit is its SI unit is what? Ampere per meters. This is the SI unit of current density. And why this is important? Because if you want to understand the microscope form of Ohm's law, This is very crucial, right? This is very crucial. So let us understand what is the microscopic form of. So to remember the microscopic forms of Ohm law, what we will write? We will write that what is, we have to remember what is this? What is this? What is this thing? Do you remember? Guys, remember what is this? VD.
Say VD.
Yeah, so what is this? VD, I can see that. We can see that VD. What is this thing? So this was drift velocity. And do you guys remember that what was this drift velocity? Right, this was
Yes, sir.
V. Yeah, so this was V equals to U plus 80, U was 0. And acceleration you guys calculated that was QE by M. So EE by M and then tau. So this VD guys, yeah, you guys have to remember. Second thing that we have to remember is relation between I and VD. So these two things and this current density, these three things, if we remember, then we can write the microscopic form of the law. So recall what is the relation between I and VT. What was the relation? Do you guys remember? What was I? What was current in the form of VT? What was current? That was NEA. If I'm correct or incorrect, please tell me. Is this correct?
Yes, sir.
This is correct. So if I take this I in the left hand side, so that would be how much? This is I by A and NE and VD. And recall what was this VD? This was acceleration, which was EE by M, and then the average time. So this was the VD, right? Yes, you guys
Yes,
remember?
sir.
So if we put this value in here, so that would be how much? I by A is current density, J, right? N, and this is how much? E tau by M. This is so if we write this thing, so this would be how much? This would be N E square E tau by M. And if we write this part, if we take this part in the right hand side, so this would be N E square tau by M, and this is E. So this part we call as conductivity. So what was the conductivity? Do you guys remember? That was sigma, right? This was the conductivity. So then we can write J as sigma E, and this is called the microscopic form of, right? Where sigma is conductivity which is represented as n e square tau by. This is the Ohm's law of microscopic form of Ohm's law. And if we write it in vector form, so in vector form, that would be how much? So in vector form, this J would be sigma, and so this is what we call the microscopic form of Ohm's law. Is this thing clear? Do you guys have any doubt, any question that you guys want to ask?
No,
Then,
sir.
okay, then please, please yeah, whenever you guys want me to scroll down the screen, please tell me. These are the prerequisites that we require to solve the microscopic form of so this is macroscopic, this is microscopic. So these are, this is Ohm's law in macroscopic form, this is microscopic. Yeah, whenever you guys want me to scroll down, please.
Yes, sir. Scroll.
Yeah, noted, guys.
1 second, sir. Sir, a bit.
Oh, is this okay?
Yes, sir. Yes, that was okay, sir. Yes, sir. I'm
Yeah,
done.
done. Okay, you guys please revise. Otherwise, there are lots of things covered. And if you guys don't revise, then you guys will right. We are human, and tend to forget quickly. Please revise all these things. Otherwise, you guys. So now, what did we got from microscopic form? We got conductivity, which was Ne square, Ne square tau by m, right? So this is conductivity. So from this conductivity, what we can calculate? From this conductivity, we can calculate resistivity. Resistivity was reciprocal of conductivity, right? Resistivity is opposing nature, and this conductivity is supporting nature, right? Opposing, supporting. So they are totally opposite, reciprocal. So this resistivity would be 1 by conductivity. So this would be how much? That would be m by n e squared tau. So we see that this is the nature of material, and this rho depends upon what? This depends upon mass of the electron, that is fixed. This is dependent upon this number density, right? This is dependent upon charge, and this is dependent upon the relaxation time. These are the four factors on which the nature of the material, resistivity of the material is dependent upon, right? So, yeah, this was about resistivity, this was about conductivity, and we have another activity. And what is that called? So, so another thing is mobility, right? What is mobility? So the ability of mobile electrons, right? So it is the measurement of the movement of mobile electrons, right? So the measurement of movement of mobile electrons in electric field, right? So what are the mobile electrons? Because you have this conductor, right? You have this conductor, and in conductor you will have those free electrons, right? Because the conductor is made up of those compounds. Those compounds have those atoms. So in those atoms, one would be the free electrons, and then other would be the combined, the non-free electrons, which are in the group. So one is valence electron, the other one is this co-electrons. So valence electron is the free electrons, right? And in those electrons, so those electrons will act like mobile electrons, and those electrons are necessary for this conduction, right? Those electrons are there for this current. So when the current is, when there is a current, so that is only due to these mobile current electrons. These electrons are free, not the interior electrons, right? Only the free electrons are, so those free electrons are called mobile electrons, right? So this mobility is defined as mu, and this is the velocity movement in the electric field, right? One moment, guys, give me one moment. There is some personality to it. So you guys, in the meanwhile, please note it down. Please note it down. So if we have conductivity, we have resistivity, and we have mobility. These are three ET, right? So please remember these. And one. So let me also solve this thing. VD is how much? That is E E. Okay, one. Yeah, so I'm back, guys. So what was VT, right? So always remember that this VT is acceleration into time, right? Acceleration, we know that that is F is QE and F is M into A. So you can always calculate this acceleration by E by M. And then you multiply it with tau. So then you will get VT. So E tau by M divided by E. So what you will have, this E tau divided by M. This E will cancel and mu would be simply E tau by M. So that is the mobility, right? You can either calculate with velocity or you can calculate with this. These are the three things: conductivity, resistivity, and mobility. So please note it down, and then we'll understand about temperature dependence of resistance and yeah, temperature dependence of resistance and resistivity. The thing that will, okay, please, yeah,
Yes, you're done.
yeah, okay, very, yeah. So this is mobility. Now let us understand temperature dependence of resistance or resistivity. Both behave in the same manner, right? Resistivity. So both have a similar manner. So R is resistance at some temperature that is equal to, that is write as RT. That is initial temperature and 1 plus alpha T minus T naught. So let's say that initial temperature T naught is the initial temperature and similarly R naught is the initial resistance. Similarly at temperature T, so this T is the final temperature, right? And then this RT is the resistance at temperature T. This is the crucial relation, right? And similarly, the resistivity varies the same. So this is rho naught and 1 plus alpha. This is T minus T naught, where alpha is the temperature coefficient or coefficient of temperature. So as you can see that what would be the unit of this alpha? So you see that this R, right? This R will cancel each other out. So unit of alpha is 1 over T, right? Which is degree C inverse, or SI unit would be degree Kelvin. This would be temperature coefficient, right? So we will do one question from the NCRT, and then this would become more clear. So it is that question, and that question is very important, right? So let me bring that question here. Let me bring that question here. What is this? Right? I guess this is the question. So now what do we have? An electric toaster, right? An electric toaster uses nichrome for its heating element. When a negligible small current passes through it, right? Its resistance at room temperature is found be 75.3, right? So its initial temperature is how much? What is T naught, guys? What is the T naught? And we have to remember that how the resistance varies. So resistance varies as R naught 1 plus alpha T minus T, right? So T naught is given. This is how much? That is 27 degrees, right? Also, R naught is also given. That is 75.3. Now, when the toaster is connected to a 230-volt supply, the current settles after few seconds to a steady value of 2.68, right? So you have the voltage, which is 230 volt, right? Now the current is so settled at this amount, right? So current is 0.68, right? So from these two things, from these two information, what you can calculate, guys? Because this toaster is heated, right? Initially, when it was not connected to the voltage supply, so the toaster was switched off. Now you are connecting it to a voltage supply. So then it is switched on and then it is getting heated and then you are toasting that whatever the toasting is, right? So at this amount of current, the current is settled. And you were providing this voltage. So from these two, what you can calculate, what you require in these question. What are the things? You require resistance, you require final resistance, initial resistance, alpha, T, T naught. So from V and I, what we can calculate? Epsilon and V, what we can calculate from V and I? Please think and tell me that in these things, we have already this thing, we have already this thing. So we have these three parameters, and what are the parameters, or what is the parameter specifically that we can calculate using this information? Yeah, we have three parameters which are left, which are unknown. So what is the thing that we can calculate using these two given things? Please, you guys have to think about it. Right? Yes. Okay, so what we can calculate? You have voltage, you have current. Are you guys there? Yeah, you guys are here. So what we can
Yes,
calculate from V and
with
I, what we can calculate?
with V and I,
We
it's
have,
voltage and current, right?
yeah,
Uh,
this is voltage and current. Can we calculate this coefficient, temperature, resistance? What is the thing that we can calculate from V and I? We know Ohm's law. What is Ohm's law? So what it will do?
so it
We have
will R is equal to V
by
by I.
so this we can calculate, right?
Yes, sir.
So this is the thing that we can get from here, right? Because the current is settled at first it was getting heated, and then current is settled at this point. So then we will get the amount of resistance provided by that heating element, micro booster, at certain temperature. So RT we can calculate. RT would be V by I. So this is how much. Let me use the calculator. By I. So 30 divided by 2.6. That is 85.8. This is the resistance. RT is 85.8. So resistance has increased or decreased. This was the initial resistance. Now the
Sir,
resistance,
it's increased.
it's increased, right? Now, what are the things that we know now? We know this thing, we know this thing, we know this thing, and we have these two unknowns again, right? So in this question, the temperature coefficient of resistance of nichrome averaged over the temperature range is this thing. So alpha is also alpha is 1.70, 10 to the power minus 4 degrees C inverse. So this is also given. Now we have all these values, so what we can calculate? This thing we also know. So what we can calculate, this is the unknown, right? Let us calculate that. What would be this thing? So this RT is this R naught 1 plus alpha T minus T naught, right? So RT by R, this would be how much? RT by R naught. This would be 1 plus alpha T minus T, right? So RT by R naught is how much? This is 85.82 divided by 75.3 equals to 1 plus alpha t minus 27. This is how much? 85.8 divided by 75.3. This is 1.1397 and equal to 1 plus alpha t minus 27. So this would be how much? 1.1397 minus 1. This would be alpha t minus 27. This is how much? Minus 0.1397 and let me write it as 2 equal to alpha t minus 27. So this is how much? 0.1397 divided by alpha. Alpha is how much? 1.7 into 10 to the power minus 7. Right. This is t minus 27. So if we write this thing, right? Let me write it in the terms of 4. If I write 4, so uh, this would be how much? 1397.2 divided by 1.7 equals to t minus 27. Because this 10 to the power 4 goes upstairs, let me write it. It will not eat up these steps. 0.1397 10 to the power 4. 1.7 t minus 27. This would be how much? This is 1397.2 divided by 1.7 equals to t minus 27. So this is very much. And divided by 1.7. So this is 821.88 equal to t minus 27. So t is 821.88 plus 27 plus 27. This is 848.88 degrees. So you guys can imagine. You guys can imagine. You guys have those toasters at your right. You guys have those toasters. So the toaster was at 27 degrees, right? Now the temperature of the toaster has become what? 848. So that is 8 times at the 100 degrees centigrade temperature. So boiling water is 100 degrees centigrade, and that is 8 times the boiling water. So that much hot that toaster is. So do not touch that toaster, right? If it is switched on, do not touch that toaster. That is the lesson that we see from this calculation. So this is the answer. What is the answer that we are getting? 847, right? So this is we are getting 848. Yeah, that is the RDC. So you guys, did you guys understand this part?
Yes, sir.
Yeah, please note down. So just look at the equation from the NCERT and note down the solution.
Yes, sir.
Whenever you guys want me to scroll down, please Yeah, whenever you guys want me to that.
Yes, sir. Done.
Then, so please this part.
Yes, sir.
Yes, noted, guys.
Yes.
Then we'll do this another question, right? Exactly the same, but yeah. So take question. Now this is the question. So the resistance of platinum wire, resistance thermometer at the ice point is 5 ohm, and at the steam point is this. When the thermometer is inserted in a hot bath, the resistance of the platinum wire is 5.795. Calculate the temperature of the bath. Right. So what do we know? What do we do? This question, I want you to calculate the temperature of the bath. So we have to find out this T, right?
Yes,
This
sir.
T we have to find out. So the resistance is 5 ohm, and then at 100 degrees C it has become 5.23, and then at some temperature it has become 5.795, right? So you guys can tell me that the temperature has been increased, right? This is the increased temperature that we have. So what are the things that we have? So we have temperature at let's say T naught, that is how much? That is 0 degrees C, right? And R naught is how much? That is 5. And then you take it at steam point. Steam point is 100, right? So that is, let me write it as T1. That is 100 degrees C. And R at 1, that is 5.8. So then at, let's say, some temperature, it has become this question mark, and we want to find out what? R is given or RT is right. Or T is given, which is 5.795. So you have right. You have initial temperature, and then this temperature, and then this temperature. Right. So what do you guys know? You guys know that at this temperature, right? At this temperature, resistance would be RT1 would be how much? That would be R naught 1 plus alpha T minus T naught. Right, guys? Right.
Yes, sir.
So from this thing, what you can calculate? What are the given things that you have? You have RT1, you have R naught, you have T naught, you have T1. So all these things you have. So what you can, I have written this as R1, right? R1. So what we can calculate from this thing? What we can calculate? Yes, guys, what we can calculate from this? Yes, what we can calculate? This is at 0 degrees C. This is at 100 degrees C. Resistance is 5 ohm. Resistance is 5.23. Resistance is 5.795 ohm. Temperature is want to find out. This is the thing that you find out. So from these 2 points, we know this resistance, we know this resistance, we know this temperature, we know this temperature. What we can calculate if you look at this formula, what you can calculate? What is the unknown in air? What is the unknown? Yes,
Sir, T.
T, you already, I'm asking about these 2 points. First, we are looking at these 2 points. What is the unknown in here that you cannot, that you, the formula, what is the unknown that you have? You know R1. Yeah, did you guys understand this question? Did you guys understand this question? So let me again repeat. So you have a resistor at 0 degrees. You have a resistor at 0 degrees C. Its resistance is 5. Now the same resistor, you increase the temperature to 100 degrees C. The resistance becomes 5.23. Right. So from these, forget about the next thing. From these things, what are the known? The known things. T naught is known. This is 0 degrees C. T1, let's say, you know that is 100 degrees C. R naught, you know that is 5. R1, you know that is 5.2. So if you write R1, that would be R naught 1 plus alpha T minus T naught. Let's say T. So what are the known things that you have? This is known. This is known. This is, what is the unknown that you have? Yes. What is the unknown that you have? Arslan and Mir.
Sir, yeah, alpha, sir.
Alpha, that is the obvious one. Alpha is not known, right.
Yes, sir.
Alpha, so from this relation, what we can calculate? We can calculate alpha,
Yes, sir.
right? So we can calculate alpha from here. So what would be alpha? Alpha would be R1 by R naught, and this is 1 plus alpha t1 minus t. So R1 is 5.23 divided by 5 and 1 plus alpha t1 is 100 minus 0. So we can calculate what would be alpha. So 5 divided by 5.8. How much is 5 point divided by 5? So 1.046, 1 plus 100 alpha. This is 0.046 equals to 100 alpha. So alpha is 0.046 divided by 100. So this would be how much? This would be 0.00046 degree C inverse. And if we write this thing in this way, 4.6. So how much we have moved? 1 to 10 to the power minus 4 degree C inverse. So this is the alpha that we have got. Okay. Now let's again make the same diagram. So we have this T1 temperature, and from this T1 temperature we are going to this T unknown temperature, right? So let me write it. From T1 temperature, which is 100 degrees C, we are going to unknown temperature T. This thing we know 5 point. This thing we know 5.795. We know also alpha, which is 4.6 into 10 to the power minus 4. So we have RT. This is R, let's say, node is 1 and 1 plus alpha T minus T1. Because we are going from T1 temperature to T temperature. So RT is there, R1 is there, alpha is there, T1 is there. What we can calculate? What we can calculate? The unknown temperature. So RT is 5.795. R1 is 5.23. 1 plus alpha T minus T1 is 100. This would be how much? 5.795 divided by 5.23. This is 1 plus alpha T minus 100. So 5.795 divided by this, how much is that? 5.795 divided by 1.108 equals to 1 plus alpha T minus 1.108 minus 1 alpha T minus 100. This is 0.108 equals to alpha T minus 100. So we divide this alpha and then we will get T minus. Alpha is how much? That is 4.6 into 10 to the power minus 4 and T minus so 0.108 and there is 0.3 also, right? 0.3 into 10 to the power 4 divided by 4.6 T minus 100. This would become 1080.3 divided by 4.6 equal to T minus 100. So how much is that? Minus 1 and then into and then divided by 4.6. So 234 0.85 equals to T minus 100. So temperature would be how much? That would be 100 plus. This is how much? 334.85 degrees. So you can imagine that how much hot this thing is, right? So this is the temperature of the resistance. Did you guys understand? So we had two process. One process was that we increased the temperature from 0 to 100. Then the resultant resistance was this, and then we increased the temperature from 100 to some other temperature, and then we got the temperature was 330. Yeah, that got 345, right? So yeah, maybe there are some different things, but yeah, this is also correct. Okay, this is also correct. Guys, please note down this one. Okay, please note it down. And if you guys have any question, please. Yeah, whenever you guys have noted it down and you want me to scroll down, please. Whenever you guys have noted it down,
Yes, sir. Done.
done. Okay, then please down. So 7.7.
Yes, sir. Done.
Done. Okay, so this part also noted. Yeah, this part also noted.